let's take a look at G-GPE.A.2. This is a nice building step from the previous objective, which was about circles. And you can see we transition to the parabola. The parabola is also derived or developed using the distance formula or the Pythagorean theorem. And so this is a nice step from the circle. Follows in a nice progression. And so we're going to derive the equation of a parabola. Then we're going to graph it, of course, and then look at characteristics based off of the equation. What does the equation tell us? So in this case, because we have a y-squared parabola here, we are looking right or left. Because we are a negative value, we are looking to the left. Normally, when we solve this, we have 4p here. So -2 is our p-value, or our distance to the focal point, things like that. So lots of things learned from the equation. And then going the other way, so give some information about focal points or directrix or vertex or p-values, and then find the equation from there. The big idea, of course, is again connecting the geometry to the grid and connecting us to some of the conic sections, the parabola. Our pitfalls, of course, is we're starting to get a little more algebra heavy here, and so you got to be aware of that. Most of the parabolas, most all of the parabola work I do is with vertex at 0, 0. Certainly you can expand that a little bit further if you want, but to keep it in the level of simplicity, that's where we operate. And then in terms of reflections, I guess just slow down here a little bit, allow them to get used to those values. The one thing that kind of trips them up is just basically transforming an equation. And so we can have an equation look like this. Okay. They don't mind it in this format. They don't like it too much when we transform it into this one. Mostly because that 4p is now in a denominator situation, and solving for values of p get a little trickier, but a good thing to practice because that's an essential skill in any math student.